At the next presentation, we'll continue our online bridge. It will be a SNO-CNZ representative again, Alexey Peshkun from the same center. He will speak about the building of 3D terrain models using Resurs-P materials. Good morning, dear colleagues. I welcome all the participants of the conference. I will tell you now about 3D models, which were built based on the materials acquired from the Resurs-P satellite. I need to refer to yesterday's very interesting reports about 3D models, but I will tell you about 3D models not as about the end product, but rather an intermediary product with which we can assess the source material that these 3D models were built with and geometry of these materials. The source materials to build 3D models were the images acquired by the highly detailed cameras of Resurs-P. You can see their characteristics on the slide. And in order to build 3D models, we used two-level processing data that include 1A and 2A processing. Both sets of materials are provided with RPC coefficients. Both sets of materials are usable for subsequent photogrammetric processing. I will tell you what is the difference between them. Here you can see also the characteristics of other equipment mounted on the satellite. This are the characteristics of the hyperspectral equipment that was mentioned during our online connection or video conference with Moscow. These are the parameters of the satellite, the different modes of imaging. Here you can see the stereo imaging on one orbit and some of the experimental reports to build 3D models. We did three stereo imaging on orbital labs, and here on this drawing you can see the rays of one color, the deviation of the satellite in the next orbit. You can see that we did two stereo imaging and one triplet imaging. And this stereo pair from one set orbit and with the triplet, we built two stereo pairs C and D. We didn't build a stereo pair from the opposite orbits because the convergence was too high there. We built a total of 8 stereo pairs. Here in the table you can see their characteristics. We called 4 stereo pairs as the main ones. They're the stereo pairs generated based on the material on one orbit, and 2 additional stereo pairs. I tried to show them on the schematic on to the left. There are based on the routes from different orbits. Here you can see the schematic of placing checkpoints and control points that we used to assess the results of processing at all stages. We had a few of checkpoints and control points and 76 checkpoints. Now I'll tell you about the material processing at the level of A1. Here you can see the table, the results of equalization of stereo pairs based on the materials of level A1, and the green color in this table highlights the 4 stereo pairs which we believe have the lowest error based on the external orientation. As you can see, the error level in terms of maximum values can reach, for all stereo pairs, can reach 4 meters. for altitude or height up to 11 meters. The best stereo pair shows the maximum error value for no more than 1.5 meters and for height no more than 3-meter error. Here, in fact, it would be more interesting to speak about other stereo pairs which are not highlighted by green. These are the stereo pairs where the results of orientation prove to be a bit worse. Here you can see that all of those 4 stereo pairs, their stereo pairs B, F, E, and G, have images from the stereo pair B, and perhaps some geometrical distortions in those images contribute these errors to all those stereo pairs. So what are these A1 material processing level? That would be source image, which has distortions, geometrical distortions explained by the vibration of the equipment or movement of the equipment during the imaging. And all these movements are then registered by the onboard equipment, but it's very hard to take it into consideration with all those RPC coefficients. As a result, if the equipment is stable during the imaging, we get better result, and if there is some sort of vibration during the imaging, the results is not so good. So for the 4 stereo pairs, ACD and H, we had 4 3D models, and we assessed their accuracy. We built the 3D models using PhotoMod, using the new module of building dense models, and the results are shown here on the slide. There is a table to the right which shows the precision of digital terrain models, and there's also a digital DSM model. It's marked by number 5. This is the DSM based on all 7 images that we had used during processing. And on the last model, on its accuracy was impacted by the stereo pairs with worse accuracies after the external orientation. These are digital terrain models. The maximum error is about 9 meters, and the RMS error is no more than 4 meters. And next, we took same routes, but the different level of processing, A2 in this case. So what are these materials of A2 processing? These are the materials which have been transformed on the medium surface, and when transforming these images, we take into consideration the external orientation of each line, taking into consideration the data received from the onboard equipment of the satellite. That is why the data for A2 processing would be easier to describe with RPC coefficients. And here you can see the results of orientation of same stereo pairs. And as you can see, the results are much better, about 2 times better than the results of orientation of stereo pairs built based on the materials of A1 processing. Here, the only thing which is worse in terms of accuracy is stereo pair F. On this schematic, it is marked by a blue sector, but we expect that maybe it is explained by the relatively low level of convergence. Other stereo pairs, though, have much higher level of accuracy, as I mentioned earlier, than the A1 processing material, and we selected the best stereo D, and used it to build a digital terrain model. So this is the result, and that is why we had some cloudiness. That's why we have gaps in this DSM model, and we used it not as a final product, but rather as a product to assess the source material. Here you can see the assessment of the precision or accuracy of DSM based on stereo pair D. The maximum error is 3.7 meter. The RMS is a bit more than 1.5 meters. And the second DSM was built based on all 8 stereo pairs using the same new module of PhotoMod, and the result is visualized in a table form. Here I can note that all the digital surface models were built automatically without any filtration whatsoever. In principle, if we also filter it properly and do some manual adjustment, you can get DSM that you can work on later on. And here you can see tables next to each other on the 2 levels of processing of the source material, which you can use to compare the accuracy level. And you can see that 2A processing has invariably higher level of precision and accuracy. And this is the DSM model built based on the materials of the 2 levels of processing. That's it. Thank you. Thank you for your presentation. Any questions for the speaker? Some people believe that when acquiring the second image of stereo pair with a reverse pitch, you can have bad geometry of the image. Did you notice it in your work? And what was the actual relief of the area that you photographed? Thank you for the question. Stereo imaging was done in the town of Hobart, Australia. The relief is well known. It is mountainous there with big fluctuation of altitudes. Speaking about deviations and geometry with the back pitch of the equipment, we didn't consider it because during the processing I didn't notice anything like this. And to be honest, I've never heard about this before. Well, thank you for the tip. I think we'll look at it once again. Just that the equipment doesn't have time to stabilize itself during the pitching motion. Can you repeat it once again, please? There is a belief that equipment doesn't have time to stabilize during the reverse pitching motion. Well, in fact, it is the like a regular mode of operation for this equipment for reverse and forward imaging. You could ask the designers of this equipment about this. Here we used the materials. No, we used it only from the first resource. We do not split this equipment because they're not principally different, but if somebody's interested in this, about this, we can also do the same thing for the second satellite, and we can jointly look at it, at the first and second one. Now many people know, I think, that the flight testing of the 2 satellite constellation is ending, and this, I think, experiment would be very relevant. More questions? Can you tell us, please, these stereo data, are they commercially available? If yes, then how much? At least give us a ballpark figure. How can we buy them? Thank you for the question. Unfortunately, I'm a technical specialist and I cannot comment on this issue, but today you had a video conference with Moscow where the head of the federal agency said that everything is sellable. Well, there were no further details that he didn't say that everything can be sold, but it is possible that you can buy it. Governmental users, of course, can get this data for free, but as far as commercial use is concerned, I'm not sure. To continue on this question, okay, later on. Can I have the headset, please?
I'm wondering, for using for computing the root mean square errors of the digital elevation model, digital surface model, what type of reference did you use?
Да, что-то непонятно, что тут.
Опорные точки. Опорные точки.
Я понял.
I understand. In my presentation, I will go back to one of the slides. I told you that on the overall area of imaging, we had about 7 control points for orientation of stereo pairs. And for assessment of digital DSMs, we also used checkpoints. How did you get those points? I think that was the question. How did you get those points there?
The source of the checkpoints.
Да, источник. Откуда опорные точки? Информация.
Вы знаете,
I was not looking for them. I was provided them as a developer. I cannot comment on this, how we got them. It's more like a question for me, I think. When there were big errors with the 7 images, for instance. To be honest, I forgot. You took different things and then got the weighted average or something. Were there any priorities in what points should be taken or not, or any correlation criteria? It's more like a question for me, maybe. Like all of these 7 images are mixed together when measuring DM. I think Dima will answer this question, how it is calculated for DM building. If there are no more questions, then I would like to thank our speaker once again.